This is Abhishek, Master Teacher of Physics at Vedantu, and welcome back to one another Sprint Tech series. Now, truly thank you to each and every one of you. I was just reading out the comments for all the previous Sprint Tech series, and I was really amazed to see that how much you guys have been missing us, isn't it? Yes, so for that we are back with another Sprint Tech series, and this is going to be the session 1 for today. And I believe all of you guys must have seen the teaser as well. And what we're going to cover in this Sprint Tech series, one of the most important things which every one of you in CBSE 10 standard must have been doing already, or they are going to start. And what is that? That is nothing but solving as many sample papers and previous year board papers as we can, isn't it? Exactly correct. And this is what all this Sprint Tech series is about. So in this Sprint Tech series, what we're going to do basically is we are going to cover the previous 2018 board paper from CBSE, as well as we are going to cover 2019 sample paper released by CBSE, and also one of the most amazing mock test papers which has been created by Vedantu according to CBSE syllabus. So these are the three things which we are going to do in this Sprint Tech series. So once again, a huge hi to each and every one of you and a high five. And I believe that all of you guys has been missing me at least a bit, because I missed you guys a lot. Let's get started then. So guys, people who don't know me, once again, my name is Abhishek. I'm one of the master teachers at Vedantu for physics. Going ahead. So today what we're going to cover. So as I said, we're going to start with the 2018 CBSE board paper. So we have the CBSE board 2018 paper we're going to cover up today. So in physics, basically we'll be taking 2 sessions to cover up each paper. So now I have categorized this particular paper basically in terms of their chapter. So we'll be covering up today, starting right from the chapter which is nothing but the light chapter, reflection and refraction. And we have realized that this chapter came in 2018 for about 7 marks, including the practical based questions. I know many of you guys have been asking us, sir, try to give us questions for the practical based part also. Practical part jo section B hota hai question paper mein, wo bhi karana aap. And don't worry, we have got that for you right now. Okay? So including that particular question, we have 7 marks, which we estimated already in previous webinars and master classes. After this, today we'll be also covering one of the most important things, that is nothing else but the human eye and the colorful world, which also came for 5 marks. So in total, the chapter, the unit optics or light, takes 12 marks. Our estimation was it should take 12 marks, and we have got 12 marks for 2018 paper as well. So amazing, guys, be ready for that. And apart from this, we also are going to cover electricity, which has come for 8 marks in total, followed by magnetic effects of electric current, which came for 5 marks, and at the end of the day, sources of energy, which came for 4 marks in the 2018 paper. ठीक है, लेकिन ये 3 चीजें हैं, we'll be doing this in our second session for this particular paper. Today, we are going to cover all these 2 chapters. Various kinds of question, and also don't worry, the entire session PDFs will be able to be downloaded by each and every one of you. So don't worry about that. You just have to go to the Sprint Tech page after this session is done. Take it, we'll share the link for that as well. So let's go ahead, guys. Let's get started. Before we start, as always, many students told me, sir, aajkal hame quotes kaun batayega? So we are back with the quote. What is the quote today? This is one of my favorite quotes. Minds are like parachutes. Why? Because they only function when they are open. So my dear students, open your minds out, let them work, let it flow, and let's conquer the first question for today. Now, as you can see, we are going to start from the light chapter. Let us try to categorize in terms of marks as well. So as you can see, this question came for total marks 2, and you can see very clearly in examination you can take 2 to 3 minutes to do it, but since this is sprint, we're going to take only 1 minute. Let's get it started, guys. Let's get it started. Let's see how to do this problem. I want everyone to concentrate on the screen right now. Let us focus on it. And trust me when I say this, हमने जो भी questions किए ना हमारे master classes में and in the previous sprint techs, these questions would look super simple to all of you guys right now if you have been following our videos. Super simple. And you'll be like, bus. And trust me, that's how CBSE is. You can do it and you can score 100%. Look at this question. If the image formed by a spherical mirror for all positions of the object placed in front of the mirror is always erect and diminished, what type of mirror is it? I mean, Come on, it's so simple. Always erect and diminished. There is only one mirror which forms always erect and diminished image, always a virtual image. And which is that mirror, my dear students? Without any issues, can say option A or option B. I truly know you know the answer. That is nothing but convex mirror. That is superbly great, guys. You guys are awesome. Yes, convex mirror is the correct answer, guys. Exactly. Now for this, you will get 1 mark. Bus. ये कॉन्वेक्स मिरर लिखने के लिए आपको मिलेगा 1 मार्क. कॉन्वेक्स मिरर फॉर्म्स ऑलवेज अ वर्चुअल इरेक्ट एंड डिमिनिश्ड इमेज. मिल गया. ओके, नाउ ड्रॉ अ लेबल्ड रे डायग्राम टू सपोर्ट योर आंसर. नाउ दिस पर्टिकुलर पार्ट विल कंटेन 1 mark again. Here you have to make 2 ray diagrams to justify that your statement that for various positions of the object you will be getting the same position of the image, saying that it will be always virtual erect and diminished, and these 2 images are the same from the NCERT textbook. Which are those 2 images? Let me show it to you directly, and trust me when I say this, when you download this session PDF notes from the Sprintex page and also from the Doubt tab, you will very clearly see that the solution is included. Yes, my dear students, the solution is damn as well as included. Now if you notice, we have captured the images here with the correct answer. Yes, it's damn a convex mirror which always produces a actual erect and virtual and diminished image, and these are the 2 images which we would have to draw. Now if you notice in the first image, what we have done basically, in the first scenario the object is supposed to be at infinity, correct? So when the object is supposed to be at infinity, with respect to the convex mirror, which property I'm going to use to make the ray diagram? I'm going to use one of the properties of ray diagram, which is nothing but all the light rays coming parallel to the principal axis, after reflection must converge onto the focus or must appear to converge at the focus. तो यहाँ पे आप देखोगे, यहाँ पे all the light is coming parallel to principal axis. Since it's a convex mirror and a convex mirror is always a diverging mirror, what will happen to these light rays? These light rays will reflect backward. It will go diverged out. So what will we do? We will project them backward and we'll get the focus. So this is one kind of ray diagram which you have to draw. Now the second ray diagram which you have to draw in this scenario is this one. This will carry half mark. Now this is going to carry another half marks. So in total half, and this 1 mark you will get total 2 marks. Now what is this image? Now here the object for the case of convex mirror can be kept anywhere between the pole and infinity. Between the pole and infinity, this object can be kept anywhere in the scenario and always will be getting an image in front of the focus. There is no issues at all. You'll always get the image here and you'll always get a virtual erect and diminished image. There should not be any doubts in this scenario. It's a very, very simple question, and you can very clearly see what are the 2 properties which we have used. One of the properties is the same, the light ray parallel to the principal axis after reflection gets diverged out. Second light ray, all the light rays trying to pass through the center of curvature goes undeviated. Same light, isn't it? That's all, guys. That's all you have to do. It's a very simple question, and I believe you guys have got it, and the correct answer is obviously convex mirror. बहुत बढ़िया. So this is how you score 2 marks. Repeating again, these sessions are directly given to you, providing you the proper solution with the exact marks, with the marking scheme for each and every line you write it down. This is why these sessions are for. Going ahead, question number 2, one very important question. Look at it very carefully. Come on, I'm like, is this a hard question? The answer is no, sir. Super simple question. 2018 paper, guys. 2018 paper, such a simple question. State the laws of refraction of light. Come on. We all know what are the laws of refraction of light. We'll say that. Explain the term absolute refractive index of a medium. A direct 1 mark part. Correct. So ये अभी है आपका 3 marks का question. As you can see very clearly, in examination can take 3 to 5 minutes, but here in Sprintex, not more than 2 minutes. So what are the laws of refraction of light? You'll be getting 1 mark for that. Explain the term absolute refractive index of a medium. You'll be getting 1 mark for that. And then the final part, write an expression to relate it with the speed of light in vacuum. You'll get 1 mark for that. So total 3 mark. यहाँ पे एक भी गलती हुई, you will lose 1 or the half marks, but I don't think you should lose here. So first let's target what is the refraction of light. ठीक है, तो जल्दी से समझते हैं कि refraction of light क्या होता है. So let's look into this particular image right now here to help us out to understand this very, very carefully. What do you notice? You have 2 mediums. Let this medium will call as air and the other medium let's call as water, correct? Then you have the boundary between air and water. Light ray travels from one medium, enters into another medium of a different optical density. Yeah, refraction, optical density. The light ray bends either towards the normal or away from the normal. correct? Now let us try to understand what are the laws of refraction of light. What are the laws? Law number one is almost equal to the second law of reflection, isn't it? A law of refraction is actually equal to the second law of reflection, where we state in second law of reflection, that is, all the incident ray, the reflected ray and the normal lie on the same plane at the point of incidence. Same यहाँ पे भी वही है. The incident ray, the refracted ray and the normal all lie on the same plane, the boundary, at the point of incidence. The incident ray, the refracted ray and the normal line all lie on the same plane at the point of incidence. And what is number 2? I think the number 2 law is the most favorite for each and every one of you. It states that if this is the angle of incidence and this is the angle of refraction, it states that the ratio of sine of angle of incidence to the sine of angle of refraction is equal to a constant value, and this constant value is one of our Mr. Mogambos which we have been talking about lately, and that is nothing but that Mr. Mogambo is whom? Is nothing but Mr. Refractive Index, our Mr. Mogambo. Yes, that's Mr. Refractive Index. Got it? Yes, exactly correct. So I'll rephrase both the laws again. It's nothing but the incident ray, the refracted ray and the normal all lie on the same plane at the point of incidence. Law number 1. Number 2, the ratio of sine of angle of incidence to the sine of angle of refraction is equal to a constant value, which is, that constant is equal to nothing but the refractive index, could be denoted as mu by some of you guys, could be denoted as n by some of you guys. Completely cool. Okay? Very simple statement. You have got 1 mark here. Now, there are few of the questions which could be twisted in a way. तो अभी आपको laws of refraction बता, they will ask you what are the Snell's law of refraction. Many students have a small misconception कि only the second law is called as Snell's law of refraction. The answer is no. Both the laws are together called as Snell's law of refraction. Please keep that in your mind. So even if the question asks you write down the Snell's law of refraction, you have to write down both of them. You cannot write down just the second one. That would be a big mistake which you're going to do. Okay? So I hope you got that particular point. Yes, now the law is done. Now they ask us one very important thing, that is nothing but, अच्छा मुझे ये बताओ guys कि what is the absolute refractive index? Now absolute refractive index, we have always remembered it with the formula, which is nothing but basically if I change the color, it's nothing but mu is equal to C upon V. Correct? This is standard formula which we have always studied absolute refractive index, and that's how it is. Mu is equal to C upon V, where mu is the refractive index, C is the speed of light in vacuum and V is the speed of light in any medium possible. Correct? So how will I define it? It's nothing but the absolute refractive index is a ratio between the speed of light in vacuum to the speed of light in medium. I've defined it, we have written the formula. Now we have got 3 marks here. Balle balle, amazing. Let's check it out. Let's check out the answer also. Yes, here is the solution. As you can see very clearly, laws of refraction, both the laws, and second law ka formula bhi likh diya, sin I by sin R is equal to constant, and we have written the third part, what is absolute refractive index of a medium. We have written down the statement. You can then later write down the formula as well, which is mu is equal to C by V. For this entire part, you'll be getting a standard 3 marks, guys. Easy, right? Isn't it? It's damn easy, definitely. So without spending any more time here, let's go ahead and solve the third question. Now, as you can see, till now we have not been doing any numericals because there was no numericals as such from light chapter in this particular examination. I have no idea why, but electricity se bahut sare numericals aayenge. So maybe in the next session we'll be more into numericals, so be prepared. We are trying to cover up both theoretically and numerically each and every board paper, guys. So let's go ahead. Okay, अब आगे बढ़ते हैं, देखते हैं कि इसका आंसर क्या हो सकता है. Now here you can see it's again a very interesting 3-mark problem which came for 3 to 5 minutes. You can write down 3 to 5 minutes, but here in sprint we'll do it in 2 minutes. Now ये जो क्वेश्चन था ये और में था, चॉइस में था, किसके साथ? पिछले वाले क्वेश्चन के साथ. ठीक है, सो दिस वाज इन और, सो वी आर डूइंग बोथ द और क्वेश्चंस हियर. ठीक है, लेट्स चेक इट आउट. नाउ व्हाट इज मेंट बाय द पावर ऑफ अ लेंस? स्टैंडर्ड स्टेटमेंट. Power of a lens is nothing but the ability of a lens to converge or diverge light to a point. Simple scenario? Yeah. So if you have a convex lens here and this is one of the lenses, I'll make this convex lens a bit more fatter. थोड़ा बना देते हैं. और ये जो आपका लेंस है ये आपको कन्वर्ज कर देगा यहाँ पे, तो ये आपका बनेगा फोकस. लेकिन ये जो लेंस है आपका, ये आपका कन्वर्ज करेगा यहाँ पे. करेक्ट? थोड़ा जल्दी करेगा. क्यों? because this is the property of the lenses. If you have no idea about it, let me just bring it down in a very simple manner कि focus हम कैसे define करते हैं. अगर आपको define करना है focus, मैं बता देता हूँ कि कैसे कर सकते हैं, ठीक है. So basically we know one very interesting thing that the radius of curvature is equal to twice of the focal length. या तो मैं ये बोल सकता हूँ कि focal length is actually half of radius of curvature. We know that formula. तो ये जो lens है, if I make the complete circle out of it, correct. So in this scenario we can very clearly see somewhere here would be the radius of curvature because center होता है, correct, r या तो c मान लो आप, एक ही बात है. ये हो गया आपका r. Half of this will be the focal length somewhere here. This will be a focal length. Same case if we try to do into a fatter lens, let us try to do same aperture. We'll reduce down the aperture a bit, but this becomes a fatter lens now. It's very fat now. Now if I try to make a circle out of it, you can very clearly see the circle will be like this. So center of curvature will be lying somewhere here for this particular lens here. Center of curvature यहाँ पे कहीं मिलेगा, करेक्ट. तो आप समझ सकते हो कि फोकस मुझे बहुत कम एरिया में मिल रहा है यहाँ पे कहीं मुझे आई थिंक आई शुड मेक प्रेडिक्टेबल वन हियर इन दिस सिनेरियो, वरना आप लोगों को और कंफ्यूजन हो जाएगा इस मामले में. तो मैं क्या करता हूँ, इसको थोड़ा सा कर्व बनाता, करेक्ट. तो अब अगर मैंने इसको सेंटर कंप्लीट किया, somewhere here will be my center of curvature and the focus will be somewhere here. So as you can see very clearly, as the aperture decreases, center of your radius of curvature also decreases, क्योंकि aperture छोटा होता है, छोटा रहा है. तो आपका जो circle है वो ऐसे हो रहा है. तो क्या हो रहा है, आपका radius जो है कम हो रहा है, correct. So your power also keeps on increasing because we know a very standard formula, P is equal to 1 by F. तो जैसे फोकल लेंथ कम हो रहा है, आपका पावर वैसे बढ़ रहा है. So basically this particular kind of lens could be a more powerful lens than this particular lens because it has a more power because its focal length is very much minimum. It is able to converge the light here itself, whereas this particular lens is converging the light here. A very big difference here. So guys, this is one of the different type of questions which you might get in a twisted way in the examination. So just making you aware of that. ठीक है, ये दो डायग्राम दे दिया. They will ask you which one has more power. What will you do? You will make the center of curvature. You make the circle, make the center of curvature. Focus, बात खत्म. Correct. Going ahead. Write its SI unit. I'm pretty sure you all know the SI unit of power is D. That is diopters. Perfect. Going ahead. So basically you have got 1 marks for this. Till here, my dear students, even if the SI unit is not asked, you have to write down the SI unit. See, I'll tell you for 1 mark what and all you need to write for a definition. You need to write down the definition of power. You need to write down the formula of power. You also need to write down the SI unit of power. Then only you'll get a 1 mark. If it's asking you to define power, you need to write down all these 3 things. It could be anything. Instead of power, they can ask you anything else. What is electric current? You need to write all these 3 things, otherwise you will not be getting the full marks. ठीक है, याद रखना, यहाँ पे बहुत बच्चों की मार्क्स छूट जाती है, इसलिए बता रहा हूँ मैं. ठीक है, okay, awesome. Now let's go ahead and see what's next with us. A student uses a lens of focal length 40 centimeter, another of minus 20 centimeter. Okay, write the nature and power of each lens. Nature, though, I think we have studied enough and we have a very clear idea. Since the focal length is positive in the first scenario, let me rub this out. Okay, awesome. Okay, so let me just write it down very clearly here. Since the focal length in the first scenario is 40 centimeter and it's a positive value, I'm pretty sure you know that which lens has a positive focal length. It's a convex lens. Hence, the nature and the power of the nature of the lens is convex in the first case. And we'll go ahead for the second case. Second case में आपको जो मिला है, obviously आपको मिला है focal length negative. So f is minus 20 centimeter. Which lens has a negative focal length? The answer is concave lens. Exactly correct, guys. You guys are super smart. बहुत बढ़िया. Now, where do the students do mistake here when we have to find out power? What we do basically is, generally since we are in the flow, we'll write down power in the first case is equal to 1 upon f, and 1 is divided by f is nothing but 40. This is the mistake which we'll do in the case of power of a lens. Very, very important. My dear students, power of a lens, SI unit is diopters. What is SI unit? SI unit is diopters. और SI unit तभी होगा जब the entire thing in the formula are in its SI unit. तो यहाँ पे f सेंटीमीटर में है, SI unit है नहीं. So we need to convert this into your meters to actually get the proper value. So 1 by f is equal to 1 by 40 centimeter convert किया meters में, you will get 0.4 meters. So 0.4 आया, which is equal to what? It is basically nothing but कितने बार होगा ये? This will be your answer as basically 0.4 कितने टाइम चलता है? 2.5, yeah. So 2.5 diopters, positive value. Simple scenario. Got the idea? Yes. Positive answer. Then it will be in diopter. So don't do this mistake of putting down centimeter directly. Cool? Okay, moving to the next part. Second, power is equal to 1 by f again. So 1 by f is again 20. So what will it take? Minus 0.2. Yes. Which is equal to, this will be, I'm pretty sure it will be going on for minus 5 diopters without any issues. Yes, negative 5 diopters becomes the correct answer. Let's have a check whether we have got these answers right or not. So yes, we have defined power. After defining power, we have written down the formula, it's SI unit, and after doing that, we have written down the equation, the formula, and we got the answer. Same thing we have done for the second lens, and we have got the second lens also. So the nature of the first lens is convex lens. Yes, the nature of the second lens is concave lens. It's diverging and converging. वो भी हमने mention कर दिया. So you have got total 3 marks here as well. So superbly well done, guys. You guys are doing really great. Let's move on to the next question. Okay, now this is oh, I think this is the same question now, right? Moving ahead. Answer. Oh, I'm pressing up. My mistake. Yes. Here is a very good question, which I think is a very easy question as well. क्योंकि ये 5 marks का question है. मतलब देख के लग नहीं रहा यार ये 5 marks का है. Isn't it? It's so damn simple. In examination, you can take 5 to 8 minutes to do this, but in this sprint right now, you will not take more than 3 minutes. You can understand it very, very clearly. तो एक बार जल्दी से देख लेते हैं कि इसका आंसर क्या होता है, ठीक है? अब देखते हैं. A student is unable to see clearly the words written on the blackboard. So it's pretty sure we don't have to do anything. When the moment says कि okay sir, we are sitting inside the class, we are not able to see the blackboard. That means we have myopia. बस क्योंकि we can't see far away things. We have short-sightedness, also called as myopia. So I'm pretty sure कि आगे बढ़ के यही क्वेश्चन आने वाला है कि डिफेक्ट क्या है. I'm pretty sure without even reading we can understand. Let's read it out. Okay, at a distance of approximately 3 meters, name the defect of the eye. Yes, right, exactly. So name the defect of vision of this boy. Poor boy. You can write down the answer as this poor boy from a very poor village has very poor myopia. मत लिखना, मजाक कर रहा हूँ. myopia लिख देना सिर्फ काफी है, ठीक है? Yes, so this person has myopia. State the possible cause of this defect and explain the method of correcting it. This is a very good question. Now many students might get myopia correct, लेकिन I have heard from all my regular students here that they are not able to understand कि sir NCERT में जो diagram दिया गया है ना, okay we can mug up and you know put it down in the examination, but what is the actual meaning of that diagram, of that correctiveness? Let me show you guys that diagram so it becomes more clear to you, but I think I will give you a statement. 1 mark you'll be getting for the defect name, and then state the possible causes. You'll be getting 1 mark there, and then for drawing this diagram you'll be getting 1 more mark. So 3 marks for the A part, and for the second part you'll be getting 2 marks. Why do stars twinkle? तो उसके लिए आपको मिलेंगे 2 marks और, ठीक है? तो 3 mark ऊपर 2 mark नीचे. अब देख लेते हैं कि इसका आंसर क्या है, और इसके आंसर के लिए ना हम इस डायग्राम को अच्छे समझते हैं. ये बहुत इंपॉर्टेंट डायग्राम है. तो आई हैव टोल्ड मेनी ऑफ माई गाइस, ऑल माई स्टूडेंट्स एवरी टाइम, डिफेक्ट्स इज अ वेरी इंपॉर्टेंट क्वेश्चन. नाउ 2018 में मायोपिया था, हो सकता है कि इन 2019 इट वुड बी हाइपरमेट्रोपिया. प्रेस बायोपिया के चांसेस बहुत कम होते हैं, लेकिन हाइपरमेट्रोपिया का चांसेस बहुत ज्यादा है. इट कुड बी अ रिपीटेटिव मायोपिया अगेन. सो माय डियर स्टूडेंट्स, दिस डिफेक्ट्स क्वेश्चन इज ऑलवेज इंपॉर्टेंट, स्पेशली द करेक्टिवनेस पार्ट. सो लेट अस ट्राई टू अंडरस्टैंड दिस वेरी क्लियरली, देन यू कैन अंडरस्टैंड हाइपरमेट्रोपिया इन द सेम वे. Okay, let us take the case of a myopic eye. This is the diagram which you have to draw in the examination, ठीक है? So we have taken the case of a myopic eye. What is a myopic eye? Myopic eye के सामने, मतलब यहीं पे कोई चीज हो, there is no issue. We can very clearly see the stuff. It's very closer to us. तो imagine करो ये जो O है वो एक object है. And this object is very closer to us, so we can see somewhere about 1 meter, somewhere about 1.5, 2 meters. We can very, very clearly see things. No issues with that. तो वहाँ उस object से light ray निकले, it got converged by the convex lens of our eye, and it got exactly focused on the retina. So yes, if it is exactly getting focused on the retina, we are able to see stuff very clearly. So this is the object very closer to us. Now, with this object, when we are trying to focus something far away than that, like it's beyond 5 meters, 10 meters, we're trying to see things, we are not able to get it with clarity. This is what happens here. You can see very clearly. If now the object position changes to a new position, O से O dash हो गया अभी, what happens? वहां से light rays आएंगे and the light rays falls on the convex lens, and now if you notice it is not converging on the retina. The answer is no. It is converging before the retina, which is actually myopia. Agreed? Now why does this myopia happens? There are two basic reasons. Myopia क्यों होती है? That is the reasons why it happens. There is also question one of them parts here. So what is the reason? There could be only two reasons. Number one reason, your eye is elongated. तो convex lens is trying to focus on the retina, लेकिन retina ही वहां पे नहीं है. That's all. You can very clearly see यहाँ पे convex lens focus कर रहा है, लेकिन focus कहाँ जा कर रहा है, वहां पे retina ही नहीं है. It is elongated. So what happens here? Since your eyeball is elongated, your convex lens is not able to focus on the retina because lens का तो size same है, लेकिन retina बढ़ चुका है अभी. Correct. So the eyeball has become longer. So number one point is nothing but elongation of the eyeball. What is it? It's nothing but elongation of the eyeball. Number one scenario. What is number two? Number two is pretty simple scenario. It's nothing but elongation of the curvature. Elongation, flattened lens, I believe. Yes. Number two is nothing but the flattened lens. जब आपका lens बहुत flattened हो जाता है. Oh, 1 second. It could be extra curvature. It's not flattened lens. यहाँ पे भी बात आती है, अगर convex lens ले लेना, ये सेम चीज हम पढ़ रहे थे पावर के बारे में, करेक्ट? लेंस जब ऐसा है, इट्स एबल टू फोकस हियर ऑन द रेटिना. लेकिन अगर आपका लेंस ऐसे हो गया तो ये वहां पे फोकस नहीं कर पाएगा. करेक्ट बात है, ये यहीं पे फोकस करे, लेकिन रेटिना आपका यहां पे. सो व्हाट इज दिस? दिस इज नथिंग बट द एक्स्ट्रा कर्वेचर ऑफ द लेंस. तो ये भी हमने अभी पिछले क्वेश्चन में पढ़ा, करेक्ट? सो आई कैन राइट द सेकंड रीजन एज द एक्स्ट्रा कर्वेचर ऑफ द लेंस. Due to this curvature, the power of the lens increases, due to which the convergence happens before the retina. Cool? Okay, so we have understood the first diagram, we have understood the second diagram, we are talking about the third diagram. In the third diagram, what is happening? Correction for myopia. So to correct our myopic eye, we will obviously inputting a concave mirror, because concave lens is nothing but a diverging lens. So all the light rays now, look at it very, very carefully. All the light rays coming from the new position of the object, also coming from this particular position of the object, enters the concave lens. Concave lens diverges the light rays a bit, then it falls on this particular lens and it now converges. तो पहले light rays ऐसे जा रहे थे and it got converged here through our lens. अभी light rays ऐसे जा रहे हैं and then it got converged on the retina. Got my point? So what is happening? Diverging lens just diverges the light a bit, ताकि convex lens के थोड़े extra area पे पड़े ये, और जब ये अब इसे converge करे, वो converge थोड़ा आगे जाकर हो, and that's when it happens on retina. So this is the crux of this diagram, guys. अगर ये समझ में आ गया तो आप कोई भी correction का diagram easily बना पाओगे. So amazing, guys, बहुत बहुत बढ़िया. So I'll repeat all the statements again as soon as we go forward. And एक और question था बहुत important इस part पे कि why do stars twinkle? Explain. It's pretty simple, guys. Stars always twinkle due to atmospheric refraction, isn't it? When the light rays, I think we have covered this in a very much detail in the Sprintex video. So if you have not seen the Sprintex video, I refer you guys, I suggest you guys to watch it up. Very clearly we have explained there. Why do stars twinkle? Twinkle is nothing but when the light rays passes through the atmosphere, what happens? It continuously refracts, because the atmosphere is made up of different gases, and all these gases have different optical densities. They have different refractive indexes. So what happens is when they start passing through all of them, it refracts, and then it reaches your eyes. So what happens? Let me draw a diagram and show it to you very, very clearly. ठीक है? तो imagine करो, एक बंदे को ले लेते हैं यहाँ से. किसको ले ले उठा से? यहाँ से उठा लेते हैं. हमेशा मैं राहुल को उठाता हूँ कोई, तो यहां से एक इमेजिन करते हैं कि लेट्स टेक इट एज रोहित. राहुल को छोड़ दिया, रोहित को उठाते हैं. ठीक है, नाउ इमेजिन दिस इज रोहित, ये स्माइलिंग विद गुड हेयर, दैट्स रोहित राइट नाउ हियर. रोहित इज ट्राइंग टू सी अ स्टार. ठीक है, रोहित इज ट्राइंग टू सी अ स्टार, एंड इफ यू नोटिस रोहित स्टार है रोहित का. रोहित और स्टार के बीच में एटमॉस्फेयर है, ठीक है, बेसिकली एटमॉस्फेयर है। दिस इज नथिंग बट आरपी। व्हाट इज आरपी? रियल पोजीशन ऑफ द स्टार। कूल। अब क्या होगा? नाउ लाइट रेज विल कम फ्रॉम द स्टार, लाइट रेज विल कम फ्रॉम द स्टार, reaches this atmosphere, refracts, then it reaches Rohit's eyes, correct? Then it reaches Rohit's eyes. Now if you notice, light rays coming in this direction for Rohit. So for Rohit it will look like that the star is here, and what is that? That is the apparent position of the star. वैसे ही हमारा जो एटमॉस्फेयर में गैसेस है, it keeps on moving from here and there. It's not like atmosphere is stationary, no, right? It keeps on moving from here and there. So अब क्या होगा? Same चीज नहीं होगा. Since the movement of the thing is happening, the light ray will come, refract, and then reach here. तो अब दिखेगा राहुल को कि पोजीशन स्टार यहां पे, अब वो थोड़ी देर बाद यहां पे रहेगा, फिर थोड़ी देर बाद यहां पे रहेगा, correct? So it keeps on changing. So apparent position of the stars keeps on changing. So sometimes you see the star here, sometimes you see the star here, sometimes he sees the real star, sometimes he sees the apparent star here. So what happens basically is that he sees different stars in every microsecond, due to which it feels like the star is twinkling. It's changing its position, due to which it is twinkling. Cool. So guys, yes, I want you guys to understand very clearly. I hope you understood it right now. And the same question can come for the case of planets. Stars twinkle को निकाल के ये question पूछते हैं कि why do the planets not twinkle? What will the answer for that? It's pretty simple guys to understand. The planets are so closer to us, basically so closer to us that ये जो apparent positions बनेंगे ना, बनेंगे, जरूर बनेंगे, apparent positions बनेंगे, लेकिन these apparent positions will be so close to the planet that will not be able to differentiate between the real position and the apparent position. So when you're not able to differentiate between the apparent and the real position, you can't see apparent position. You only see real position. That's why do not twinkle. ठीक है? So many friends have asked me this question. I believe you have understood that particular part. Yes, guys, going ahead. So proving back again कि whatever you understood till now. Causes of myopia. Eye lens becomes more converging. Yes, that is the extra curvature of the lens. Going ahead for elongation of the eyeball, he had myopia. Methods of correcting myopia is nothing but concave lenses, and this is how we will be correcting it. You also got the answer about the twinkling of stars, which is basically due to atmospheric refraction. Now, my dear students, going for the final question for today. And this final question, if you notice very clearly, it's a practical based question, and yes, all the practical questions comes for exactly 2 marks each. There will be basically 6 questions for section B, जहां पे एक question physics होगा या तो 2 question physics हो सकते हैं, तो but all the questions will be for 2 marks. Cool. So 6 into 2, 12 marks क्वेश्चन आते हैं सेक्शन बी से, which is practical based. तो इसको ध्यान से कर लेते हैं. ये बहुत ही सिंपल सा क्वेश्चन है, and you should not take more than 1 minute to do this in this sprint. लेकिन एग्जाम में ले लेने ज़्यादा टाइम, it's okay. This is a very proper diagram based question. What is this question? An object of height 4 ये आपको literally बनाना है. This you have to make it very clearly. An object of height 4 centimeter is placed at a distance of 30 centimeter from the optical center O of a convex lens of focal length 20 centimeter. बना देते हैं. I don't care about anything else. We care about convex lens. Okay, so if I roughly take a convex lens, I think I should draw it here. Yes, this is your convex lens. Optical center F2, C2, F1, C1, correct? Awesome. Now they say that the object is the height of 4 centimeter, do not care, is placed at a distance of 30 centimeter from the optical center O of a convex lens focal length 20 centimeter. Okay, so the focal length in this scenario is 20 centimeter at both the ends. And now you have, if both focal lengths are 20, then obviously your center of curvature will be at 40. बना दिया? Correct? बहुत simple सा बात होगी. Correct? Now the object distance is 30. That means that the object is kept between focus and center of curvature because it has a distance of 30. तो 20 और 40 के बीच में 30 आता है. तो यहाँ पे बनेगा आपका exactly at the center. It will be your object distance, which is nothing but 30 centimeter. Now, my dear students, do I have to say anything else? The object is between center of curvature and focus. According to our ray diagrams, we know a very clear thing. If the object is between center of curvature and focus, in the case of a convex lens, the image must be formed beyond C2. Isn't it? It must be formed beyond C2. Now, by using the convex lens formula, we can find out where the image distance is, isn't it? Let's quickly find it out. So 1 by f is equal to 1 by v plus 1 by u. So yeah, minus 1 by u. Yes, 1 by v minus 1 by u. We need to find out 1 by v. 1 by v will be equal to 1 by f plus 1 by u. 1 by v is equal to focal length convex lens का है तो पॉजिटिव होगा. So 1 by 20 plus 1 by minus 30 u है तो नेगेटिव. तो इसका आंसर क्या होगा? 1 by v is equal to minus 30 plus 20, so minus 10 divided by 20 into minus 30. Negative negative cancel. You must get a positive value because it's on the RHS. So v becomes equal to 10 ones are 10 twos are 60 centimeter. So yes, ये distance क्या हो गया आपका? 60 सेंटीमीटर. यू मस्ट गेट ग्रेटर देन सेंटर ऑफ कर्वेचर वैल्यू, क्योंकि सेंटर ऑफ कर्वेचर 40 पे है, उसके बाद बन रहा है, तो v का वैल्यू 60 सेंटीमीटर होना चाहिए, पॉजिटिव होना चाहिए. बस इतना ही है और यह पूछा गया. ऑल्सो फाइंड द अप्रोक्सीमेट ratio of the size of the image to the size of the object. That means they are asking us to find out the ratio of h dash by h, size of the image by the size of the object. What is the formula? We can write down this as equal to magnification, which is equal to nothing but v by u. v और u दोनों है, ठीक है. तो h dash by h is what? 60 divided by minus 30. कितना हो गया? 2. So h dash by h is roughly equal to 2. तो that means h dash is equal to 2 times of h. मैं नेगेटिव नहीं ले रहा हूँ, नेगेटिव लेने की जरूरत नहीं है मुझे यहाँ पे, क्योंकि मुझे सिर्फ रेशियो बताना है और रेशियो इज नथिंग बट h dash is equal to 2 times of h. सिंपल एज दैट. करेक्ट कर लिया हमने. 2 मार्क्स से क्वेश्चन है, इतने इजीली कर लिया 1 मिनट के अंदर. बहुत बहुत बढ़िया गाइस. एंड द आंसर फॉर दिस क्वेश्चन इज आल्सो गिवन हियर वेरी वेरी क्लियरली विद अ वेरी गुड डायग्राम इफ यू डिडंट अंडरस्टैंड माय डायग्राम आउट देयर, एंड विद प्रॉपर 2:1 रेशियो एज वेल. करेक्ट. 2:1 रेशियो है, h is equal to 2 times h, तो 2:1. करेक्ट. Thank you so much guys, and as always I will not leave you guys as simple as that. This is the homework which you guys have to follow. It's a very interesting question coming out from human eye. That is nothing but write the function of each of the following parts of human eye: cornea, iris, crystalline lens and ciliary muscles. one line statements, क्योंकि जो top part है वो आपको मिलेगा. ये 5 मार्क्स का क्वेश्चन है. So top part has 3 marks and the bottom part has 2 marks. ठीक है, तो A part has 3 marks, B part has 2 marks. So according to this you write it down. Cool. And let me know what is the answer for this question on the comments down below. Also, you can send me the answers on my email ID, which I'll be sharing it shortly. Now, my dear students, that was the homework, and the solution is also given for the homework in the PDF, so you can download it. But answers अपने से देना, ठीक है? अब आगे बढ़ते हैं. So today what we have covered, guys? Today we have very clearly covered the light chapter along with human eye, very very clearly. In the next session, we'll be covering up electricity, magnetic field, solid current, source of energy. So be ready for that. Now, many of you guys will be thinking, sir, हमने human eye से ज़्यादा नहीं किए, क्यों नहीं किए? करेक्टिव कर लिया ना. और ये क्वेश्चन जो हमारा आई का आया था वो 5 मार्क्स का था, वो भी ह्यूमन आई से था, बट इट वाज इन और, तो इट्स ओके. ठीक है, तो हमने कर दिया. ये 3 पार्ट हमें करना है हमें नेक्स्ट सेशन में. Cool. 2018 sample paper will be 2018 board paper will be covering again. So my dear students, you can find all this session notes in this particular web page. It's the Sprintex web page. You'll be getting this particular link on the YouTube chats as this video is going on right now. Don't worry about it. ठीक है, and you can go on to this. You can download all the session notes as fast as possible. You can get it up. You can get all the papers and everything here. All the videos also. Cool. And apart from that, as I believe you must have noticed that we have also launched a very interesting Vedantu app. It consists of doubt solving, it consists of all the study classes, it consists of all the classroom notes, everything on the same app. So try logging into the app guys and getting all the notes of this sessions also and further other sessions which we have already conducted. You can find all the videos also out there. ठीक है, तो मिल देना. And at the end of the day guys, thank you so much for attending this particular session, and thank you so much for making this Sprintex series an amazing series altogether. Thank you so much guys. And if you're new to the sessions, if you're not subscribed to the channel yet, please subscribe to the channel because you're missing out a lot of information. Also, please press the bell icon so that you get notified for further all the videos which are coming up. For the next 10 days guys, we are going really hard for this particular Sprintex series. ठीक है, उसके अलावा अगर अच्छा लगा वीडियो, hit the like button, share it among your friends so that every other student gets the benefit out of it. Thank you so much guys. Once again, this is Abhishek, Master Teacher of Physics at Vedantu, signing off. Thank you so much.